Thanks for you guys being back here in time. Jack is there, so everybody should be there. What's happening? So that's today is going to be a bit different from yesterday. It's a presentation about the way that basically screening and confirmatory is performed in EU right now, especially for food and feed control. So it's just I'm just expressing here my point of view because I know many people might disagree with what I'm going to be saying, but this is just that's my feeling, let's say. So just in terms of food crisis, just if you look a little bit back to history, what I call the prehistoric event happened quite some time ago, back in 1957, with the so-called Edema factor in the US. And basically what happened at that time, which is called the first real dioxin crisis, or the American Chicken Gate, was that in the US a lot of chicken were dying, basically, like a million chicken were dying. And of course it triggers a lot of interest and people were wondering why this was happening. And basically they were tracing that back to some feed contamination. This is the classical scenario where I'm going to say the chicken manufacturer or the chicken raiser were basically asking the industry for cheap fat in order to increase the caloric content, I would say, from the animals. So they received some fat which was absolutely not dedicated or prepared to be used as a feed additive, so that the oleic acid was used there. But the oleic acid was from beef hides, from tanning industry. And in this industry, they were treating the piece there with pentachlorophenol to avoid bacteria growing, etc. So obviously, you can imagine that if you treat that with PCB, and then in between, the time that the fat is collected there, it's reprocessed, heated, etc., you're producing dioxin. So they were basically offering oleic acid that was really highly contaminated with dioxins, and then that end up in the feed, and then that end up in the chicken, and they were basically dying. So, if you look to the level, there was ppm level. So we are used to play with ppq nowadays, so that was ppm level, which is sky-high levels, and this is the reason why the chicken were dying, basically. So that happened around like 1957, and this is one of the first paper I found, like it's, was submitted in 1967, so 10 years later, where they were finally able to trace that back to a dioxin contamination. So they were doing a lot of research, and they were finally, doing characterization of at least one of the molecules that were present there, which was one of the hexadioxin there. So they were doing full characterization, and this was called then, this molecule was called the Edema factor, basically. So that's one of the first reports from the first dioxin crisis back in the US. So from that, of course, now that you know what is the causal agent, you have to develop methods to basically analyze and measure if this compound is present in the food or the feed. So a few papers were published a bit later, like 1972, where they basically were developing a very simple method to try to have a rough idea of the quantity of that compound that was present. So that was separated based on chlorination levels. And from that time, it was a lot of papers around. They were kind of showing recommendation how to avoid such crises, basically. We know that we haven't learned that much from that because like 40, 50 years after, we still have this type of crisis. But still, at that time, they were saying, okay, avoid to mix anything that has been close to pentachlorophenol with feed ingredients. That was the conclusion. And it sounds obvious, but still today, we have this type of problems. So the so-called Chicken disease, basically, that's really the beginning of the story in terms of food control for dioxins. And it has been since then quite some incident, even in the early 60s, 70s, that were always related to this type of situation. But in the point of view of the analytical chemistry, this is really when everything started. So it's not that long ago, actually, that people have been able to analyze dioxin in food and feed. And it has been some early papers there that were very focused on trying to get good analytical methodologies, plus the toxicologists were also starting to work on those compounds because it was potential high danger there. And it's interesting to think that in the same time, that was the time where Agent Orange was spread massively during the Vietnam War, and that was also some sort of chlorinated, phenol-related contamination there. It was not pentachlorophenol, but trichlorophenol related. But then, that's everything happened in about the same time, in between, let's say, the 60s and the 70s there. A little bit after, like it was two events in Asia, the Yusho and the Yu-Cheng incident in Japan and in Taiwan, like 10 years apart. But that was the same scenario where for both of those crises, where it was some chloracne cases that were reported because of the consumption of contaminated rice oil. And the thing is that during the process of the oil, there is a deodorization process where the oil is heated, and a good heat exchange fluid is this PCB mixture. So we can imagine that if you have even a very small leak in these pipes, which are basically used to heat transfer, if the PCB mixture is leaking in the rice oil, I mean, you can imagine that you have big contamination. So that was a big event, and those cohorts are still, they're still followed today, basically, in terms of health effect of that. Closer to us, and especially to me, because that happened in Belgium, the 99 crisis was again about chicken dying, and again about fat that was contaminated with improper fat that was not basically supposed to end up in the feed. So quite some high quantity of fat were contaminated. So that fat was used to be incorporated in the feed, so a lot of feed was contaminated. The quantities are not huge, but again, we're talking about PPQs or PPTs. So when we have, let's say, 1 gram of pentafurane, it's already something big. And it was mainly, of course, a PCB contamination. So in Belgium, we have a lot of friends, so we share our feed with our neighbors. So the crisis was not only in Belgium, but also spread on the neighboring countries at that time. So that was a big event there. And this is just, I'm not going to go in detail in this, but just the chronological scheme, basically, of that dioxin crisis, where it took quite some time, again, to realize that it was a dioxin contamination. Back on the American Chicken Gate, it took about 10 years. On the Belgian Chicken Gate, it just took a few months, but still, it's not acceptable that something happened in January, and then in June, that's the first time that things are removed from the supermarket because we think that maybe the population might be exposed. And even worse, I mean, during all those events, by the time chicken were dying, they were kind of remixed with the feed that was used to feed the new chicken. So it sounds like the mad cow disease issues where you re-inject the problem in the food web, basically. So it was some reinsertion of those dioxin, and basically it was a 4 months of potential exposure for the population. And at that time, a lot of people shifted from chicken to fish, which might also be quite, even more contaminated. So it was a big issue in Belgium at that time, and it was very scary because that was one of the first time in Belgium where the authorities has to go to the supermarket and say, oh, excuse me, I have to remove this meat from the shelf because you might be in danger if you eat it. So in terms of impact on the population, this is really something that should be avoided. So I like this picture because this is from a paper we published in a French journal that was in '99. That's the time that the French were winning the football cup. So they were very proud of being the world champions. So they had this picture where the French chicken is there and the Belgian chicken was on the first place on this because we were higher in dioxin. So on that we beat the French people at that time. So we were proud of that. But if you look to the exportation number more seriously, you can really see that there is a spike, a negative spike in the exportation in terms of money that the country was doing. So it has a huge economical impact on the top of the potential health issue. For that reason, we had to change the government. We are quite good at that. And it cost quite a lot of money. So it's huge, again, it's huge economical impact on the top of the health issues. And we heard about numbers of goats that were slaughtered earlier this morning, but in that even, it's 7 million chicken that were basically trashed, basically because of that, and also some pigs. So it was mainly concentrated on pigs and chicken for that crisis. So this is where I would say this is T0 on the time scale of the European legislation. It was, of course, already some legislation in Germany here and there, but it's really the Belgian dioxin crisis that shake the stuff and say, okay, we should do something at the EU level to try to avoid such situation. And you know that since then, since '99, it has been a lot of little crises that were basically spotted because of this legislation, because now there is a continuous monitoring. So obviously, if you want to try to reduce the way that we are exposed as human beings, we need to check what we eat, and even better to go one step before is to check what we give the animals we eat, what we give them to eat. So instead of even looking for the food, we can look for the feed. that's better, because then if you see some dioxin in there, you don't have to go to the supermarket and remove the meat, for example. It's more obvious, let's say, for the population. So food and feed control, and since, again, that period of time, it has been a lot of EU legislation, and even like, not even a month ago, the last part here have been updated, basically, including some non-dioxin-like PCB, for example. But there is a lot of legislation in EU just to give you guidelines on how to do the analysis, what are the maximum residue levels, what is the target level, what is the action level, about upper bound, lower bound. We heard about that before. So it's quite, I would say, easy to know what you have to do if you want to set up a dioxin lab, because the legislation is extremely complete. It's a good point in most cases. So about the strategy that is used in EU, they use the ALARA approach, basically, but also, as I said, they use the maximum action. It used to be a target level that was expected, but it was dropped quite recently. So it's mainly maximum level, so that's the maximum residue level that you can see in a food or feed item, but also there is some action level where as soon as you reach the action level, which is lower than the maximum level, you should take action to try to see, okay, we might be in front of a potential problem, let's try to reduce the level to be below this action level. So that's the strategy in the EU. Of course, we heard already several times that the sampling is very important. So uniformization of the sampling and the setup of the rapid alert system for food and feed means that as soon as something is detected somewhere in Europe, the information is sent to the EU level and spread in all the EU countries to say, hey, maybe, for example, today there is a dioxin issue with eggs in Germany, but all the official labs knows about that. They start receiving samples. So, there is a EU action basically taken, it's on alert, basically, in the EU level. So I believe those things are going in a good direction to protect our health. As I said, if we want to be sure that we avoid crisis, we have to continuously screen for what we eat. So there is a continuous monitoring program which is running. So every day, every official lab or reference lab is receiving sample from the government, checking the levels of the meat or other animal-related products which are sold in the country. So that helps to spot, as I said, small crises, from like a couple of times a year you hear in the newspaper, oh, there is a small contamination there or there, and we quench it before it goes to the unacceptable level, basically. But of course, the big issue back in '99 was that it was not possible to analyze a lot of sample on a short amount of time. So what the EU decided is to go for screening, and then in case of positive screen sample, to go for confirmatory. That's where the whole story from screening and confirmatory started, because of capacity, basically. Things are very different today because the capacities have changed. But back, in early 2000, this is the reason why screening was introduced, basically. And as I said, there is, at the EU level, the lab in Freiburg from Rainer Malisch is basically heading this reference lab network, where every country has a national reference lab, and there is also some official labs which are accredited and that have been recognized to be able to do properly the analysis. So they have to participate in PTs and things like this. But every country has its reference lab, which is also a good thing, because back in 2000, it was many countries with no dioxin reference lab. So you have to do analysis. Where do you send the sample? Or how do you know that this lab is able to do properly the analysis? So now it's extremely different. So this report was in 2010 from the European Food Safety Authority, that they were kind of compiling most of the data that had been produced the last 10 years. And those two reports are available on the web and are very interesting because it concerns a lot of sample for both PCDD, PCDF, and dioxin-like PCBs. That gives you, the rough idea of the level of, the background level, I should say, of the EU food feed web, basically for the last 10 years. So those information were missing badly 10 years ago. So now the continuous monitoring for the last 10 years has been able to produce those numbers, and still it's every day more samples are added to this database, basically. So that's for the global context of food crisis or food and feed analysis. But in terms of analchem, what is the challenge? Okay, is it easy or not today to do a dioxin analysis? Basically, that's the question we can ask ourselves. And because of the dioxin crisis in '99, it was a lot of working groups. That's some of the OHC report, like it was published in 2001, where people were getting together and try to set guidelines for the analytical part. So the analytical parts mean the screening on one side, and of course the confirmatory on the other side. So it's really the beginning of some of those criteria ended up in legislation afterwards. Just for people to agree on a set of criteria and then apply the criteria to everybody. Just a few of those criteria, ISO 17025, of course, you have to be accredited if you want to do that. As I said, the introduction of the upper bound and lower bound based on the limit of quantification that you have. You have to participate to PTs, have good Z-scores. I guess we're going to hear about that a bit later. Talking about recovery rates, chromatographic resolution, mass spec resolution, etc., etc. So it's really a good guidelines which is available today. And because of that, of course, the lab response has been increasing for the last 10, 15 years. And LOQs have been improved because the mass spec are getting more and more sensitive. The sample preparation is getting more and more complete, so less interferences, so you reduce the noise, so you improve the signal-to-noise ratio, basically. The turnover, I was talking yesterday about the fact that in our lab we do, let's say, 400 samples per person per year. So roughly now a lab can do 500 samples per person per year. So it gives you a good estimate on the capacity of the EU, basically, if you count the number of labs. The price has been decreasing. I'm going to talk about price a bit later, but most often we heard about, okay, what's the price of a dioxin analysis? Most of people say, oh, it's going to be roughly 1,000, USD, or let's say 800 euro or something. But nowadays, it's much closer. It's even lower than to 500 euros, which is much or significantly cheaper than 10 years ago. The big things also, it took a lot of efforts at the EU level to basically tune the procedure for the calyx to be used in this normative context, because the calyx is AH receptor based. So if you feed the assay with anything that will trigger a response on the AH receptor level, it will give you a positive response. But if you want to use the calyx just for dioxin and furanes, or maybe PCBs, you have to clean up the sample, because I remember at some of the dioxin meeting back in 2000, 2001, some calyx people were just coming and say, oh, we solved the issue, no problem, we have screening tools now, we don't need even cleanup anymore. But of course you need cleanup, you need fractionation. If not, the response is going to be always positive. So that's something that we have to keep in mind. And of course, the idea is to get a larger number of samples to be analyzed in case of crisis. If today there is a crisis, we need to be reactive, and then in a week from now, we should be able to have been processing 5,000 samples, for example, to check every country in the EU. So if we just look separately to the screening versus the confirmatory, screening is mainly, as I mentioned earlier, mainly done by calyx in EU. If you look to the legislation, you can do screening using also GCMS. It's also permitted. But if you really look into details, if you want to do screening with GCMS, you have to basically use the same criteria that you use for the confirmatory, except that you don't have to use a sector instrument. So if you have to deal with isotopes, dilution standard, etc., I mean, you quickly quit the idea of screening using GCMS. You buy a sector instrument and you do directly the confirmatory. That's why it's a few labs that are doing screening with GCMS, but that's basically what I feel is the reason. But as I say, it was a lot of tuning of the calyx in terms of response factor, I should say, in terms of, instead of talking in terms of TEQ, they have to talk in BEQ, so it's a biological equivalent. They have to set up cutoff values. So there is now available in the EU legislation some documents which clearly explain how you have to calculate the cutoff, which reference sample you have to use because the matrix effect. So if you want to use, screen fish sample, you have to analyze reference fish sample in the same time because you want to take into account the fish matrix effect, the potential fish matrix effect. And you have to do a milk reference or a meat reference every time. So that's quite well documented. So, as I said, very little GCMS screening. Mainly GCMS is used for confirmatory. And as I said, the legislation in EU tells you that you do have to use sector instruments. So you do have to do high-resolution mass spec, or so-called high-res, because 10,000 resolution is maybe not high-res anymore today, but still this is what is called high-res. Selected ion monitoring using isotope dilution, C13 label standard, everything is available on the market today. And we heard already yesterday about maybe the potential use of triple quads to do confirmatory, because we saw some data from Martin yesterday that he was showing, okay, very good data from triple quad, and you can even think of not only using it for screening, but maybe shift it to the confirmatory. And at the EU level, there is discussion groups working on that today. Maybe high resolution TOF, why not? I mean, this is also a potential. And of course, the big advantage of the TOF would be that you don't have to do SIM. You can do full scan and have much more data than just the dioxin data, basically. So it's a lot of discussion there, and maybe things are moving in a good direction in that in that sense. Maybe something else. Maybe it's new tools also we should consider. Ion mobility, why not? Maybe there is a potential there. We don't know, we haven't tried it. I mean, some labs are trying, but this is some other option that could potentially be used. So if now we can say that, okay, we have big capacities in the labs, but let's try to reduce the cost, because if you cut the cost, you can analyze more sample. That's always, because there is a budget in each country for that. So this is a really quick and dirty calculation exercise there, but if you just look to the comparison between the confirmatory, so GC high-res sector instrument versus the response binding assay, so it basically is the Calyx, and you look to a rough distribution of the cost, we even saw earlier today that for the GCMS, the cost of the analyzer or the final measurement was like 6%, if I remember right. So my estimation is a bit higher, but still, it's only 10 to 15% from my estimation, the real cost because of the fact that you had to buy a sector instrument. So maybe, yeah, there is some interest to move to triple quads, but if you have to make the calculation between the purchase cost of a triple quad, the capacity of, the capability of a triple quad, the investment of a sector instrument, maybe the return on investment is good enough to still buy a sector instrument. But the question is open, but that's something to think about. Of course, if you are, for example, a pesticide lab and you say, oh, I'm going to jump into the dioxin business and you already have a triple quad, might be interesting, although pesticides and dioxin are different stories. But my point is that it's less, for me, I was expecting it to be much more impacting the price of the analysis. So just shifting from high-res mass spec to another type of mass spec will not solve the complete issue of the cost of the analysis, basically. As I said yesterday, I'm a big fan of automation because I believe if you go faster, it's going to be cheaper. So automation has been, many labs have been working on automation for the last few years, and automation at all levels, extraction, cleanup, injection, data processing, data reporting, so you can save time. And as I said yesterday, we can work in day plus one today, which is a nice improvement from the previous years. So this is just an example. We saw that picture before. It's just a Soxhlet ramp, so that from that you can go to, let's say, parallel PLE or sequential ACE, depending on what you want to do. You can also go from manual silica column to automated system with multi-layer columns, or mix both of them. We do mix both of them actually in the lab. And basically this time-consuming evaporation step might now, at least partly, be replaced by such evaporation devices. So this is where the effort has been taken. So in practice, if you just talk about price, if you have to go to your government and say, okay, I want this or this money to do the dioxin monitoring program in my country, this is from the best estimates that I found. Those are official numbers. The Calyx today costs, let's say, 250 euro per sample versus, let's say, 400 euro for confirmatory. So it's still cheaper, of course, to do Calyx, but the difference between the screening price and the confirmatory price is getting smaller and smaller. So it's maybe time to rethink of the strategy that was decided 10, 15 years ago and maybe readjust that a little bit. That's just my personal feeling. Plus, the other numbers are again, those are official numbers from the EU, that this is the capacity, because there is much less lab doing Calyx, quite surprisingly, than labs doing confirmatory. So we even have a bigger capacity today in doing confirmatory than doing screening, basically, which is, for me, it's surprising. But because of that, the EU capacity in terms of crisis is bigger with the confirmatory. So that's basically the number of samples you can expect to be able to do at the EU level, including all the reference labs in case of crisis. So that's the question I was talking about. Today, maybe we should think, was the rabbit becoming a turtle and the turtle a rabbit? We might be in a position where things are changing. And the best example is this mozzarella cheese incident, where it was decided not to even go for screening. When they had the crisis, they say, oh, let's shoot all the sample on the confirmatory method directly. We will save some time, and potentially we save some money. Because if you do the calculation, it was estimated that if you are expecting the NC's non-compliance level, so if you are expecting a non-compliance rate above 30-35%, it's cheaper and faster to just directly go for confirmatory instead of even screening, because if you screen when you have a positive sample, you have to redo all the sample prep to add the internal standard, for example, and those things. So again, those are just questions that we should ask ourselves if things are still, if we are still doing the things the proper way. And I'm going to even push it further, that if you look to the regular food control, where you are not expecting high rate of non-compliance sample, And if you just take the cost of the analysis and you divide it per ton of product that has been checked, basically, we are talking about this type of number, like 0.05 euro per ton of food or feed that has been tested. So maybe instead of doing 400 euro analysis, you do 250 euro analysis. The difference in cost per ton is going to be extremely low. So even, not in case of crisis, I'm not convinced that we save really money doing screening. But again, that's my personal feeling. So if we just try to see, okay, where we are coming from, where we are, and where we will probably end up, back to the early 2000, the price was, let's say, 900 euro for one dioxin analysis using the full GC sector instrument. This, of course, was not high throughput at all. This is why screening was born. And then it was, of course, giving you a container-specific piece of information, which is interesting because when you have a crisis, it's not all to say that I do have a crisis, but you want to solve it. So to solve it, you have to be able to trace it back to the origin. So you need a pattern, basically. So, of course, this is not biologically relevant because we only analyze dioxin and furans. It's much more compounds there. But then if you look to the screening, that was, let's say, a bit less than half the price. It was, for both methods, it was still not that quick. The screening was about the same time demand than for the confirmatory, but still 5 days was already a big improvement there. But then, of course, you don't have the pattern of the compounds. You have high throughput. It was higher throughput at that time, but it was not even biologically relevant, although you were using a biological tool, but you were only focusing, and still today, on the dioxin and the furans. No idea about the other compounds. So today, we are around here, like as I said, 400 versus 250. Still, things are getting faster. We saw that yesterday, and it's interesting. This is the most recent number I found, that we go faster today with the confirmatory than with the screening. So that's not an argument anymore to say we screen so we go faster. No, we screen so we go cheaper. That's still true, but I don't know for how long. And then, of course, this situation has not changed. It's still not biologically relevant. None of those. It's just for the regulation. So if I kind of dream of 10 years from now, so for maybe one of those next POP symposium from Thermo, we will talk about that. But let's say that the next symposium happened in 2020. I could kind of hope that we will still be able to cut the cost to 400, let's say to 300. Yeah, Kyle told me that they were going to sell DFS at 100,000 euro to those people that have been attending the meeting today. So, and they're going to give you a triple quad, as a gift on the top of that. So, thanks. That's really appreciated. But that's a joke. It's going to kill me. So basically, and of course, you can also reduce the price of the sample prep for the K-Lux, so the global price, because the idea, as you're going to see here, is that I think we should move to a more biologically relevant situation with the K-Lux, because the K-Lux is a fabulous tool that should be able to give us a real information about the toxicity of a sample. Because if you stop doing fractionation and focusing only on the dioxin and the furans, you could have a larger picture of the real toxicity of the sample. So if you do that, you can simplify the cleanup, and then you can have an interesting response for the biological screening. So basically, even if you sum up those two prices, 300 and 125, it's about the same price that the price we pay only for confirmatory today. So I believe those two techniques should go together. So you do confirmatory for the legislation, and in the same time, every sample is screened for the real global toxicity. That would be nice, I think. And it should be possible in some time. So that's for the situation. And what about the other POPs? I mean, Heidi showed us the list of the Stockholm Convention. So it's not only dioxin. Dioxin is only one of the 12 in dirty dozen there. So it's a lot of compounds that we should pay attention to. And obviously, it's not trivial. You cannot just put sim descriptor and say, oh, we're going to see all the compounds. But sometimes you have to do LC, for example. So that's not an easy task. So that's where the challenge in analysis is today, to just have multiple methods that are able to measure all the POPs and the foreseen POPs, basically. Like, we heard about the dechlaranes or the, even some chlorinated short chain chlorinated paraffins are also probably of high interest. As I said, not only sector instrument, a lot of LC. We heard yesterday about some LC method. That's obviously something that has to be implemented. We heard also about GC times GC, peak capacity enhancement. Why not using higher stuff instead of using lower stuff? Jana told us yesterday that one of the big limitations from the low resolution TOF was the sensitivity. So if you can gain a bit of sensitivity doing for high resolution TOF, on the addition you can have molecular formula information. That would also help to spot new compounds. NCI is mainly used only for BFR today, but it could also be used for some chlorinated compounds. It was done in the past. It's mainly EI today because the NCI was not that reproducible a few years ago, but there has been improvement on the NCI side as well. So multi-analyte, we saw yesterday one of the methods for 400 pesticides. Wow, that's impressive. I mean, we are just measuring 27 compounds. I mean, we still have room to improve there. The maximum residue level, should we expect other maximum residue level? Because that's the point. If there is no legislation, we are not going to be wasting time and money to try to analyze compound just for the fun of it, even if there is a big interest. But if there is no legislation, nothing will be done. So the question that you can ask yourself is that, is regulation driving research, or is research driving regulation? Where should it start, basically? Because it has to start somewhere. But the question is open. I don't have the answer to that. So finally, this is the trend I would imagine for the next few years. From, if we compare that to 10, 15 years ago, the food web quality in Europe has been improving drastically. I mean, we are much safer today than a few years ago. But still, the number of targets is quite limited. We're still working on the old-fashioned selected ion monitoring, but we should expand it to other molecules. I dream of a calyx that could measure the global toxicity, the full toxicity. Maybe we have to set some priorities, but who is going to set the priorities? The scientist, or the toxicologist, or the analytical chemist? That's something that we don't know. So a comprehensive approach, I think is needed. So that's what I think would be the future for that. So yeah, all those IDs and tables and everything is available on a paper that is available online. I've got a few copies on the table over there. If you're interested in that, just grab a copy and you have all the detail of what I was quickly talking about today. So thanks for your attention and thanks for being here.